In the case of the residual interfermion, gravitational interactions acting between two masses, it leads to an increase in the strength of the gravitational interaction for larger separations so that HR becomes an increasing function of R. It is known from particle physics that the strong color interactions tend to increase with the separation of color charges, and for large separations, this increase is approximately a linear function of R, in agreement with the flat rotation curves observed for spiral galaxies. Thus, HR is expected to be approximately a linear function of R. Where G is Newton's gravitational constant, K represents the relative strengths of the modified and Newtonian gravitational fields, and Rs is a radial length scale dependent upon the radial mass distribution of the spiral galaxy so that Rs varies from galaxy to galaxy. Thus, the modified law of gravity in the GM may be written as 8 is very similar to 3 of the Mond theory, and one can relate the modified terms in the two gravitational acceleration expressions to obtain. Thus, the scale length Rs may be regarded as the radial parameter beyond which weak acceleration takes place. 9 implies that the physical basis of the critical weak acceleration A0 of the Mond theory is the existence of a radial parameter Rs that defines a region beyond which the gravitational field behaves essentially as 1/R. To summarize, gravity in the GM is identified with the very weak, universal, and attractive residual color interactions acting between the particles of ordinary matter. This gravitational interaction is mediated by hypergluons, which self-interact, leading to a significant modification of Newton's universal law of gravitation, especially at galactic distance scales. However, the self-interactions of the hypergluons cease at a sufficiently large distance as a consequence of the color confinement property associated with the QCD-like gravitational interaction. This leads to a finite range of the gravitational interaction for very large cosmological distances, estimated to be several billion light-years. 8 describes both the flat rotation curves of spiral galaxies and also the Tully-Fisher relation. This modification of Newton's universal law of gravitation is essentially equivalent to that of the Mond theory, in that both describe these two overarching observational facts. However, the GM is based upon a quantum field theory of gravity, which provides a general underlying theory of gravity and hence a more physical understanding of the Mond results. Furthermore, unlike the Mond theory, the quantum theory of gravity provides a possible understanding of the observed accelerating expansion of the universe.